Hi, today I want to talk about soft and weak structs. So what is it all about? This is an example of a regular struct. A regular struct doesn't care about the memory we use. So that means when I fill up the memory, we end with an out of memory exception. It doesn't care if we add an element, it doesn't check if there is enough memory and it have to take care of everything. No, it simply adds the element, and if there's no memory anymore, it gives an exception. So in that case, I simply have a loop 100,000 times, and 10,000 times. Then I add to a struct a very long string. You see here that string is repeated 10,000 times and added to that struct. So 10,000 times 10,000 times, and then so we have a very fast growing struct. And in the end, we simply output how many elements are in the struct and how long it took. So when I execute that, take some time. So it fills up the struct with a lot of elements, and it after some time, as you see, it breaks. You have an out of memory error. Java heap space is overfilled, so that's what we expected. There is not the memory is limited, so of course that was expected. So what could we do about that? So there's one solution for that, and that is we take the same example, but we define the struct as soft. So with struct new, we simply say the type of the struct is soft. That means that the elements in the struct do not live forever. They only live until the JVM, the Java Virtual Machine, runs out of memory. In that case, the garbage collector tries to clean up. So if there's no memory available, it removes everything that is not necessary. And that includes soft references. So all the elements in that struct have soft references. So the garbage collector comes and cleans up and see, okay, this struct, I can remove element from that struct because they are soft. So that struct cannot cause a out of memory exception, because before that happens, the garbage collector cleans up and removes element from that struct and avoids that problem. So when we execute the same again, but that time with type soft, we no longer should get out of memory exception. Instead, we should get it should run through. And when we go back to the code, and we should see that there are not 100,000 elements in the struct, because the garbage collector has removed some of them. And here we have the result. You see it has not a lot of elements because they are very big, but it has run through. So we have lost elements in the struct, but we have avoided out of memory exception. So but what is that good for? Let's do a simple example of what we can do with that. And that's this. That's a function that grabs the content of a URL and stores it. It's a simple cache for all information for an URL. So we have in the first line of the function, we check if there is already for that URL, if there is already something stored in application URLs. If so, we return that. Then in the next line, we check if application URLs exist as a whole. If not, we create that, but we set it as soft. The struct, we set a struct that is soft. Then we grab the URL data and add to that data, receive a data, we add a timestamp, and then we store it to application URLs. And return the data. So not very complicated. So in the first case, we grab the URL, it doesn't exist. It will this line will have false, so it ends up in this line and grabs the data and returns the data. And the second time, it should already have the data and returns the data. So not very complicated. And let me change that a little bit because I assume that is already in the cache. So, okay. So when we execute this, you see big difference. First time it was not cached, second time it's cached. And when now I repeat it, you see both are cached. And in difference to if we would use a regular struct and we have hundreds of and thousands of URLs grabbed, we could run out of memory because this is in application scope and it runs forever. But Lucee, the JVM will remove elements if it starts to run out of memory from application URLs. So we can use that and we are safe. It never runs out of memory. If there's a memory problem, it will remove that element from that. So that's a simple kind of cache. It's not a datetime-based cache. It's really a memory-based cache, and that you can implement in a very easy way. And of course, if the JVM removes an element, it simply grabs it again. So there's not really a problem with that. In addition to soft, we also have the type weak. So you can define with struct new, you defined weak, and that makes a difference with how the garbage collector handles them. With soft, as you know, as I said, it only removes element if it runs out of memory. With weak, the garbage collector can always remove elements. So it doesn't, if the garbage collector runs, the garbage collector can decide to remove elements. And so not only if it runs out of memory. That can differ from the JVM. So it can be that so on the Windows, it acts in a different way that it runs on the Linux, because that's not really specified how that works with the JVM specification. So it can be different. And I personally never have made use of that. And to be honest, I can't think of any test case or any example that is useful in any way. So maybe you have an idea how you can use that. So if you want a struct that loses all his elements without any real reason, you can use that. And maybe a lottery app or whatever, I don't know. So I hope this video was useful to you. Have a good one.